Hello, and today we are talking about law of sines. Of course, let's always start with a good warm-up problem. So pause the video here and try this one out. Note that the 8 feet tall is what we're going to say is that like kind of eye height, right, when dealing with the angle of elevation. Okay, so this is how you should work it out. Here's a diagram. We're going to use tangent twice. We're going to add up because of that looking back, and then divide by the total time. This gets us 681.85 feet per minute, approximately, right? Always dealing with approximation. So today we're going to be talking about the law of sines. If you do not want to stick around for the proof of law of sines, then feel free to leave. But I'm going to try to do the proof, and then you guys can follow along. So sine and cosine and tangent is deal with right triangles. So we're going to make this a right triangle. Let's make this height, call it h, and then see if we can set up some ratios. So let's first talk about the sine of A. So the sine of A, and we know sine in general is just the ratio of the opposite side over the hypotenuse. So this would be C. If we do the same thing for C, we'd realize that the sine of C is equal to the opposite side, H, over the hypotenuse. Now maybe you realize here that both of these have h in them. So let's solve for h. On this one, I'll multiply both sides by c, which gives me h equals c times the sine of a. And this one I'll multiply by a, and that'll give me, wait 1 second, that'll give me h equals a times the sine of c. I did that by multiplying both sides here by a. Now that they both equal h, I can set them equal to each other. So let's set a sine of c equal to c sine of a. This lets me kind of set up two ratios that might be helpful for us, right? I can either divide both sides by c and a, right? A from here, c from here. And that gives me sine of c over c equals sine of a over a, which is great. This is fantastic if I want to solve for angles. The other option is I could have divided by the sine instead. So if I instead divided by sine of A and sine of C, it might look a little bit different. So here I'm dividing by the sine of C on both sides, and I'm also going to divide by the sine of A on both sides. So now I have A over sine of A equals C over sine of C. And this is great if I'm solving for a side length. Either way, the big piece that we're dealing with here is we kind of want to have an angle and a side across from it pair. If we have that, then we're going to be okay in terms of solving our problem. Let's look at what this looks like in a full proof form. So this is kind of what we're dealing with. Let's see if I can shrink this down a little bit. We either have sine of A over A equals sine of B over B equals sine of C over C. If we had just essentially added in one more height, we would have been able to see this pretty clearly. Our other option is we could deal with A over sine of A equals B over sine of B equals C over sine of C. And we're not really showing the angles here, but we could call this angle A, which means that the side across from it would be side length lowercase a. This is angle B, and so this would be side length lowercase b, and this is angle C, and side length C being a lowercase. So it's a little bit harder to tell with the lowercase there. Okay, and so the big piece that we really wanted to use law of sines with is anytime we have this angle side pair, right? So let's try this out. Here's one of our triangles, right? We see an obtuse angle. But the big reason we know we're going to be using law of sines here is because we have this angle here and a side length across from us. So we're solving for x, which in this case is an angle, which tells us that we want to use our sine on top and then the side length on the bottom. So I'm going to say sine of x will over 60 will equal sine of 125, sine of 125 degrees over 100. At this point, all we really have to do is multiply, well, we need to get sine of 60 by itself, or sine of x by itself. So we're going to multiply both sides by 60 here. And this gives us the sine of x equals 60 sine of 125. 125 over 100. Now, from here, how are we going to get x by itself? That's right, we're going to have to take the arc sine. So now I'll do the arc sine of both sides. And then I'm going to throw all of this in my calculator. We don't want to essentially approximate ahead of time, because if we do, what might end up happening is we round too early. So now I'm going to put arc sine 60 sine of 125, and then divided by 100, all in my calculator at once, and that gets me that x is approximately 29.44 centimeters. Oh, sorry, just kidding, not centimeters, 29.44 degrees. Make sure you have the right unit there. So we get x is going to be 29.44. And that kind of makes sense to us, right? We know that it definitely has to be smaller than 125 because, 125 is across from the 100, which is obviously the greater side. We know it's not going to be like a crazy small amount, but we realize it's going to be definitely less than, it's probably going to be an acute angle and probably less than 45 considering the ratio between 100 and 60. So final answer, x is 29.44. So let's try one more out together. In this case, we're trying to find all the missing pieces. So we're trying to find side length B and side length C. And we kind of have a problem because we don't have that angle side length pair right away. But we realize that we already have two of the angles. So I think we can probably pretty quickly find angle A. If we just do 180 minus the sum of the other two angles, we would get that our final angle is 16 degrees. So now we have that angle side length pair, so we know that we can use law of sines. Because we're going to solve for a side length, we're going to put essentially the variable on top by itself. So b over the sine of 101, right? And again, we know that we're going to be doing this pair here. And then we're going to use 9 over sine of 16. Notice I can't use this 63 because I don't know the side length for it yet. Because we're trying to isolate b, we're going to multiply both sides by sine of 101. And so now b is equal to 9 times the sine of 101 all over the sine of 16. And then at this point, we just put it all in our calculator. And that gives us an answer of b being approximately 32.05, and then we don't have a unit here, but 32.05, which again is a lot bigger than 9, but we kind of expect that because we're dealing with a ratio of 101 degrees to 16 degrees. So that's a bit of a difference. We need to find c, which means we're really just going to do this one more time. And now instead of that 101, I'm going to use the 63 in c. So I'm going to do c on top, sine of 63 on the bottom. And then the only thing I have to do here is, again, multiply over that sine. So c would equal 9 sine of 63 divided by sine of 16. We expect this to be a little bit closer to 9, but still might be pretty close to 32. And we get c is approximately 29.09. So again, still pretty big, but 16 degrees is just such a small angle. We know that this is still going to be a triangle, one, because we have kind of like this angle side angle piece here, but also because triangle inequality, right? we know that 29.09 plus 9 is still greater than 32.05. So we know we've done something correctly. All right, why don't we try this one out? Pause the video here and see if you can solve for theta, x, and y. Okay, so we should have gotten that theta was approximately 23.75 degrees, x is approximately 46.25 degrees, and then y is approximately 10.76. If you got that, fantastic job, way to go. If not, stick around while I explain what we did. So again, the reason we know that we're going to be using law of sines is because we have this angle side length pair, right? The buddy pair. And so the first thing we can solve for is theta. So we're going to use sine of theta over 6. Sine of theta over 6 is equal to sine of 110 over 14. And so our first step is going to be to multiply 6 to both sides. And this will get us 6 sine of 110 over 14. And then our last piece is going to be to take the arc sine of both sides. So 6 sine of 110 over 14. So if we put all that in our calculator, we get that theta is approximately 23.75. Now that I know theta is at 23.75, it's really easy for me to find x because I can just do 180 minus 23.75 minus 110, and that will get me that x is approximately 46.25 degrees. From there, we're just trying to solve for y. So solving for y means that we're going to be able to set up a ratio with y on top and sine on the bottom. So we're going to go y over sine of 46.25 equals 14 over sine of 110. Then we multiply 14 sine of 46.25 over sine of 110, and that gets us that y is approximately 10.76. And this kind of matches up with everything that we had, right? We expect that because theta was the smallest angle of 23.75, it should have the smallest side length, and it does. And we knew this was 46.25, so this should have a medium side length somewhere between 4 and or somewhere between 6 and 14, and so that got us 10.76. And so we're good to go there. If you guys have any questions, please feel free to email me. Next video, we're going to look at what ambiguous cases would look like, and then we're going to tackle a harder law, which is law of cosines. Have a great day. Bye-bye.